Okay, make sure y'all get started on Schoology. If y'all haven't, please get it done soon so we can get started. Take one pass it back. Take one pass it back. Take one pass it back. And take one pass it back. Hey guys. Thank you. Take one pass it back. 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 Did everyone get 2 sheets of paper? Please be vocal. I want to hear y'all's voices.
Yeah.
So I don't want to have to say this every day. I want to hear y'all's voices. So who didn't get a paper? No one? Cool. Cool. Give me a thumbs up. Actually, no. Close your laptop when you're finished with your Schoology assignment. One, 2 finished. 3 finished. Y'all aren't gonna need y'all's laptops till the end of the day. Y'all can put them on up for now. We'll give y'all another 30 seconds. For everyone else, make sure you have your papers out and ready. Okay, if you haven't finished, make sure you submit. We're gonna get started. So, today we are going to be talking about similarity in triangles. We're going to be talking about finding the missing measures as well as being able to write similarity statements. Okay, so let's get started. So first we're going to talk about similar polygons, because we're not only be touching on triangles today. We are going to be using quadrilaterals and triangles. In the future you might even see more than that. Who knows? So, polygons for the same. So, I'm going to talk about similarity before. So, what y'all say for congruency? Same what and same what? Same, be vocal, talk. It's okay if you're wrong. Same shape and same what? This is for congruency. Same shape, same size. Congruency. So congruent, you use same shape and size. However, with similarity with polygons, you're using the same shape, but different size. Okay? Same shape, different size. Polygons are similar if corresponding angles I'm going to put an angle there. Angles are congruent. Okay? That's number one. Your second rule for thumb is corresponding sides are proportional. So, we talked about proportionality yesterday. Okay? We talked about that yesterday. We discussed it. We learned about the ratios. All that is just being tied into the triangles and similarity. Okay? The ratio of a corresponding sides is called the scale factor. Now this is just bonus points. Does anyone remember what letter would be used to signify scale factor? Does anyone remember? This is probably, I don't know if y'all have done this recently.
W.
Good guess. Not quite.
Okay.
K. Yes. You use K. Okay? So, when have you used scale factor in the past? Because you'll have. I can promise you that. I know you'll have. Y'all are so silent today. Come on, speak. I want y'all to speak today. Speak for me. When have y'all used scale factor? Maybe with like plotting points. Maybe that's going to trigger some memories. Plotting points. The shapes. Yusuf, was that a hand raised?
When we were doing the graphs and stuff, and we were turning them.
Okay, so there's a specific name. Y'all did dilations. Y'all made dilations. So when something is enlarged and reducted. So reductions and enlargements were part of the dilation segment y'all did. Okay? That's where you use scale factor in the past. So, if polygons are similar, then their perimeters are also proportional. Okay? So if they are similar, their side lengths are going to have proportional lengths. Okay? So, let's look at number 1. So what is the scale factor of triangle A and triangle DEF? Triangle ABC and triangle DEF. So, first thing we have to look at. Big point I want to make. Look at the letters. Do you see what order it's in? Okay? Let me use the highlighter for this. So we have angle A as our first letter. D, angle D. They have congruent angles. I don't know if y'all noticed it. They have congruent angles. What about our second letter, B? What about angle B? What would its congruent angle be? Anyone? Yes.
Angle E.
Angle what?
E.
E. Why? Why would it be angle E?
Because the B is in the middle and the E is also in the middle.
Exactly. It's all about the ordering of the letters in that statement. So, angle E is congruent to angle B. What about C and F? Would they be congruent? Why? Why?
Because they're both the last.
They're both the last. But if you also look at the lines, what does the lines tell you on the triangle? Does it not tell you which ones are congruent to each other? So this one has 3 lines, and this one also has 3 lines. What would that tell you? They're congruent. Awesome. So, now that we have that out of the way, I want to make sure I establish that before we even went going. So, let's look at line AB. So, let's look at line AB. What is that like? 8. We're trying to find a scale factor. So, we're going to use AB, and what's the proportional side to AB? Why? Why would that be the proportional side? Not quite. They're similar, but why are they similar? Why is AB and DE similar? Speak up, I want to hear voices. Okay, I want to raise your hand now, because I want to, yes.
They connect congruent angles.
They connect to the congruent angles. Awesome. So we have the congruent angles AB, DE. You have to have the order right. You can't say AB and ED. That is incorrect. Okay? The letters tell you everything. So, we have 8 and 12. 8 and 12. Okay? So that is the start of our scale factor. What did we talk about yesterday? When we have a ratio, a proportion, a scale factor, what do we do? Simplify. Always, always, always simplify. And what would that simplify to? Because I can't even speak today. 2 what? 2/3. 2/3. Awesome. What about this? Would that be the same? Would that be the same? Price. what is different about 2 than 1?
Triangles are not in the same order.
Exactly. That, astute observation. That is what we're looking for. If the triangles are in a different order, your skill factor is going to be in a different order. Okay? So what number represented our DEF on this one?
12.
What part of it is 12? 12 represented our scale factor part for DEF. What about triangle ABC?
8.
What?
8.
8. That looks similar, right? It's the same numbers. It's just in a different order. So, what are we to do with these numbers? We simplify. Awesome. And what would that be?
3 over 2.
3 over 2. Awesome, awesome, awesome. So, does that make sense?
Yeah.
Not losing anyone?
No.
Good, I don't want to lose anyone. We don't need lost children. Okay, so what is the ratio of the perimeter of triangle DEF and ABC? Well, if we did our math right, the proportionality between these and these two sides, it should still be the same, even if you did the entire perimeter. So let's give it a try. Everyone, I want y'all to add up the two perimeters. So add up the perimeter for ABC and add up DEF's perimeter and see if it is still proportional. If it's still going to be 3 over 2. Anyone have any numbers here? Anyone have some numbers? Yes.
48 over 32.
48 over 32. So, we end up with these lovely numbers 48 over 32. Can that be simplified?
Yes.
Yes, and what is it simplified to? What? Y'all gotta speak up, come on. 3 over 2? Awesome. Are y'all sure?
Yes.
Awesome. Thank you for being confident today. So, that's it. That is what I'm talking about. So you can see that between these two, they are the same. Why? It's proportional. Not only that, but it's in the same order. Triangle DEF to ABC. Triangle DEF to triangle ABC. They are in the same order. And if they are truly proportional, that would be the same. Okay? Moving on. So, what is the symbol for similarity? Anyone else? Okay, so what is the symbol for congruency? So you have a congruent angle. What symbol would you use to say that this angle is congruent to another angle? Dana?
An equal sign with a squiggly line on top of it.
An equal sign with a squiggly. Awesome. So, look like something like that, right? That is for congruence. So, what would you think would be for similarity? Any ideas? Very close, actually. So it's not 2 squiggly lines, not 3 squiggly lines, but 1. 1 little squiggly. And do you remember what the name was this morning? I couldn't remember what it's called.
Tilde.
A tilde? It's called a tilde. I just call it a squiggly line because I can't remember that for my life. So it is a squiggly line or tilde if you want to call it that. So, what we found in our last picture A valid similarity statement must match corresponding angles and sides. So, we write a similarity statement for the triangles that we just did. What would it look like? So, we had triangle. That's a triangle, I promise. A, B, C. Similar to triangle D, E, F. Does anyone notice something about that? Anyone notice anything? Does anyone notice anything about the order in which they're written? Anyone? Any gears turning? What, Dana? Oh, Abigail?
Alphabetical order?
So, yeah, that's true, technically, yeah. But when you're writing these similarity statements, it doesn't matter if you write triangle DEF is similar to triangle ABC. That triangle is similar to that triangle, regardless of which order it's in. Now, when it gets to sides, like I said, that can be a little tricky. Okay? You have to do it from the right parts of the side, like we talked about. Okay, so what is the scale factor? Wait, wrong side. So we're looking at triangle JKL is similar to triangle PMN. Huh? We don't have any angle signs. We have none. Okay? How would we figure out which angles are congruent to the others?
The order.
The order. So, what would that mean? So what's congruent to angle J? For example. Angle P. And how would we write that? Angle J, that's a J, I promise, is congruent. Make sure you write the congruency symbol, not symbol, for similarity. We had a little trouble with that this morning, okay? Remember when you use the congruency symbol, and remember when you use the similarity symbol, okay? It's congruent to angle P. Who would like to give us the angle that is congruent to angle K? Yes, Kayla.
Angle M,
Angle M. Why?
because it's in the same order.
It's in the same order. Awesome. Angle K is congruent to angle M. As you can see, these angles are not similar to each other. Okay? We are talking about similar polygons. Their angles are still congruent. Who would love to give us our angle L's congruent? Yes?
Angle M.
Angle N. Lost my train of thought for a second. Okay, so now we found that. Now that we know which angles are congruent to each other, let's use a little highlighter. So angle J, we'll get a little yellow, no, blue, and P. For K, we'll use yellow, M, yellow, because they are congruent. For L, green, and N, green, because they are congruent. Now, how do we find which sides are proportional? Which sides are similar to each other? Anyone? Y'all talked about this actually just a second ago. Y'all brought it up. Come on. Okay, that is A-okay. So, let's look at K. Let's look at J to K. So which colors are those touching? Blue and yellow. Speak up, guys, be confident. Y'all know colors, I hope. Blue and yellow. Which angles over here have blue and yellow? Those are those the congruent angles to them?
Yeah.
Yes. So we have a congruent angle J to P. Those are congruent. That is our starting point for both of them. We have a K with a yellow. That's congruent to M, which is also yellow. That is our proportional side. So we got J to K. Lord have mercy. I don't want that. I don't want that. J to K is similar to P to M. Does that make sense? Okay. Who would like to do, I don't know, let's see, K up. Who would like to do our K? Yes.
KO is similar to MN.
MN? Are you sure?
Yes.
Are you? Awesome. Okay, KL is similar to, you said MN?
Yes, sir.
MN. So, we have our KL, JK. Now we're looking for our LJ. Yes, ma'am.
Well, then similar to PM.
PM,
PM.
PN. Did I say JL or LJ?
Okay. Then LJ is similar to NP.
Thank you. Good job. Good adjustment. LJ is similar to NP. Now, did you notice the very specific way we lettered things? Oh, please be vocal, okay? I want y'all to talk, okay? I don't know if you'll understand if y'all don't speak to me. At least give me a thumbs up. Okay, there's like only like 3 thumbs. Okay, thank you. Okay, good, good. Thank you for the thumbs up. Does this make more sense?
Yes.
Yes. Okay, this side room's getting it. Okay, this side room. Is this making sense?
Yeah.
Okay, we had 3 people. Thank you. Lord have mercy. Okay, moving on. So, this one, same thing as last one. Okay? I want you to try 2 and 3 on your own. But I will point out one thing. Is that angle congruent to itself?
Yes.
Yeah. By what property? Did you say reflexive? Awesome. The reflexive property tells us that this angle is congruent to itself. So angle Y is congruent to angle Y. Okay, I want y'all to do the rest of it. I just want to make sure I pointed that out because people had a little trouble this morning with that. Good job, good job. Awesome job. Most y'all look like y'all are done with the first one. I'm gonna give y'all about a minute more once y'all finish the second one. Yes. So give me a thumbs up if you're finished with both of them. Thumbs up, I see a few. Give me a big hand raise if you're finished. Okay, big hand, I'm talking about in the air, wave your hand around. Come on. Oh, okay, you just literally like, I love your look, just a little wave, I love it, that's great. Okay, give y'all about another 30 seconds. Okay. Annika, would you be so kind to give me the angle congruency for the second one?
Angle R is congruent to
Angle R is congruent to what?
Angle X.
Angle X. Okay. Who would like to? Yes.
Angle Z is congruent to angle S.
Angle Z is congruent to angle what?
S.
Angle S. Do y'all agree to this?
Yes.
Are y'all sure?
Yes.
Awesome. Okay. Now, who has the side similarities? We'll call on someone. Gabriel? Do you have them?
Yeah.
Okay.
YR is similar to YX.
YR is similar. Wait, no, that's not supposed to be that. Similar to what?
YX.
YX. Do y'all agree with this?
Yeah.
Okay. Who would like to do the next similar? Well, let's see. Cameron, would you like to do it? Okay. YZ is congruent to, not congruent, similar to YS. Awesome. Who would like to get the next one? Who's going to be my next victim?
ZX is similar to SR.
ZX is similar to what?
SR.
SR. Y'all agree with this?
Yeah.
Y'all agree? Are y'all sure?
Yeah.
Okay. Just want to make sure we're all on the same page. That is correct, by the way. Awesome job, guys. Y'all did beautiful. Absolutely beautiful. Now, we have a different polygon. This is not a triangle. If y'all haven't noticed, there's 4 sides. There's 4 sides. What does that mean? You treat it the same. It's no different. Just work with it a little bit differently. Okay? You just have 4 sides instead of 3. So, who would like to give me the first angle? Caleb.
Angle J is congruent to angle Q.
Angle J is congruent to what?
Angle Q.
Angle Q. I love that you were speaking up. Thank you. I appreciate that. Yusuf, would you like to give me the next angle?
Angle K is congruent to angle R.
Angle R?
Yeah.
Awesome. Who would like to go? Have to go?
Angle S. Angle L is
Angle.
congruent to
You said
angle
L?
S. Yeah.
L is congruent to angle
S.
S. Awesome. And who will be my last victim before we get to the sides? Maddie?
Angle N is congruent to angle P.
Angle what?
Angle N
N.
is congruent to angle P.
Angle P. Okay. And who would like to give me my 3 sides? All the sides. Who shall be the big dumb? Yes.
JKL is similar to
JK what?
JKL is similar to QRS.
Come out sides. Sides.
Right, so we're gonna do, okay, so it is 4, right?
So
So
we're
JK
doing
is
one
similar to
side.
QR.
So PQ. So 2.
Okay, so
Quarters.
JK is similar to QR.
JK is similar to what?
QR.
QR. Does everyone agree?
Yes.
Yes. Okay, next one. Yes.
KL is similar to RS.
KL is similar to RS. Love that you use similar. Makes me very happy. Y'all are using similar. It makes me very happy. Does everyone agree?
Yes.
Yes. Next one. You would like to be next? Shaw's not here. Okay, I was gonna call her Dana. OM is similar to SP. No, agree. What?
LM.
Oh, LM. Okay. My apologies. LM. Does everyone agree with that?
The last one on the angles, it's supposed to be M and B, not N.
M. Said M
Yes.
as in money. There we go. I apologize for that. And thank you for clarifying that. That's wonderful. So, last one. Would you like to do it?
Sure.
Okay.
JM
JM.
is similar to B.
What? BP? QP? Does everyone agree? Okay. Awesome. Does everyone understand?
Yes.
Okay. Because we're moving to the next part. So, now we're finding the side links, using proportions, but we also have variables. Okay? We also have little lovely x's in it. So, we have this figure below that is similar with a scale factor of 2, 3. Find the value of x. How would we do that? Have any ideas?
Divide.
Not exactly. Let me show you. Let me show you first. So, we have this scale factor. Okay? We have to set that equal to the numbers that are given. So, what do we assign which one is the bigger one? Okay, the one with the x. So this is the bigger one. So, which number from the scale factor would we assign to that large number, the large square, rectangle thing? The quadrilateral. 3? Does everyone agree? Yes. So the larger part of our scale factor goes to the larger polygon. So, keep that in mind. So, we put our 42 over x, because that is proportional to 2/3. So, does this look a little more familiar?
Yeah.
Yeah, this looks like something we did yesterday. So, all we gotta do a little cross multiplication, my favorite. So, what does that give us?
63.
Hmm?
63.
63. You were all the way done. Wow, okay. Does everyone get 63? Does anyone need to see how we got to 63? I think it might be. Y'all need to see that? Y'all know it? Speak up now. Forever hold your peace. Okay? So all we did was we multiplied 3 times 42 and divide by 2. Yes, miss.
Could you not just divide 42 by 2, multiply by 3 to get 63?
That's
You
what I
can do that. Yes, there's multiple ways to do that, and that is a great thing that you mentioned. There are multiple ways of finding the answer. And me and Miss Crawford will not hate on you if you choose to do it a different way than what I would do or what she would do. As long as it's the correct answer, okay? As long as you're using a formula that is correct to use and you're finding the right answer. So, we have our lovely 63. Good job, y'all. So, let's look at our next figure. So, we have a scale factor of 6, 5. Who gets the 6 and who gets the 5? The triangle with the 6, well, with the x gets the 6. And the triangle with 28 gets the 5. Awesome. So, 6 over 5. Now, how would we set up our other proportion? How would we set up our other proportion? Yes, Dana.
X over 28.
X over 28. Does everyone agree? Does everyone see how she did that? Now, why would you put it in that order?
Because 5 is the smaller one,
Mm-hmm.
and then X goes to the larger triangle, and 6 is a larger proportion, so.
Actually, you pointed out something very good. Thank you. So, right here, we have these group of numbers, 6 and X. It is part of the one triangle, okay? All the way across. Same thing with our lovely 5 and 28, all the way across. Same triangle. You keep those proportions across the same, and it's going to save your life, okay? Absolutely save you. Okay, so who would like to give me some results? Annika.
33.6.
What?
33.6.
33.6. Okay. All agree? Awesome. Good job. I bet y'all are getting annoyed by that by now. Okay, so the correct answer is 33.6. Does everyone understand how we found it? Yes. So what did we do to find it? So some people call it the butterfly method or cross multiply. I like calling it cross multiply. That's why I grew up with it. Cross multiply. 6 times 28. Then you divide it by 5. Okay? Everyone, that makes sense too? Awesome, awesome, awesome. So, let's see. I want y'all to do 6 and 7 on your own. Actually, hold on. We're going to do 6 together. My apologies. So, with 6, we are not given a scale factor, are we? No. How do we supplement for that? How do we fix that? So, yes, Dan.
We look at the congruent angles.
We look at congruent angles, yes, but we also have proportional sides. So yes, we look at our congruent angles. So we got A and D, B and E, and C and F. So, look at those proportional angles, B and E. So, we find from that we do have some sides that we can utilize. D, and A. So, and we got, of course, C and F. So, what do we do from there? We look at the angles that we have. So, we got B to C is 28. E to F is 20. Are those similar sides? We have a few head nods. Everyone think so? Do we have any rejections? Okay, so 28 over 20 is equal to x over 25. So now you have to set it up. I would like y'all to work that out. That shouldn't be too hard. First person who has it, raise your hand. Oh, we already have. Wow. Okay. Yes, I haven't heard much from you today.
I got 35.
35. Did anyone else get 35? You got 35. You got 35. Awesome. X is equal to 35. Okay. We're going to move on. We're not going to do 7. We move on to number 8. We have triangle DEF is similar to triangle HJG. We have 2 variables. What on earth? Lord have mercy. We have these 2 lovely variables. How would we approach this? So, like we saw in the last one, we have this beautiful 15. Do we have a proportional side that we can look at to that?
9.
9. Why?
Because HJ is congruent to DE.
Awesome. So, we have our lovely 9 over here. And our lovely 15 over here. This is just going to make your life easy, the way I'm doing it. So, you have your proportional sides, right? You have your 9 and your 15. Which one would you like to do, X or Y first? Okay, X. We have X as our value we'd like to do first. Okay? So what's proportional to our X? What side is proportional to it? Any ideas? Any ideas? Blurt it out when you have it.
DF.
DF. Awesome. And what value does DF have? 12. So, y'all know the steps for this. You cross multiply, butterfly method thing, and y'all get X is equal to
20.
what? 20. So, you get 20. Who got 20 something? Got 20 what?
5.
25. Are you sure you cross multiplied correctly? So,
I did 15 times 15, not 15 times 12.
okay, that makes more sense. Did anyone else get a different answer than 20? No? No? So, now we have that side. Now what we could do is create a new proportion. So, we have our, discard that. We have our 9 over 12. We can use that again. We can use that as many times as we need. That is a proportional side. Use it. What do we set that to? So we have our y, correct? We have a y. What side is proportional to it? What is the proportional side to our y side? Hmm? EF. Are you sure? EF. Awesome. Okay. Butterfly method / cross multiply. What do you get for your Y value?
Good afternoon, class. Page your afternoon announcement. Memories are
Once
special
again, just give it
moments
to me
that tell
and we'll be
stories.
done.
Our yearbook crew has been hard at work in capturing the 2021 and
Anyone have it?
2022
Yes, Price.
story. We're at every event,
What?
game, and celebration.
Make
Snapchat
sure you
pictures
check
of
the
your
word.
friends, your teachers,
You
and
might
your
not
learning.
be.
We're only
Exactly
halfway through the year, and our
Anyone
papers
else?
are jam-packed with
It's gonna have a decimal.
photos of this one-of-a-kind year. Ensure you get a yearbook to get that personal edition order. For your
You got
gift before
18.7.
February 25th.
Oh,
Go to the people
I
who
apologize,
answer
y'all.
questions in this comment
I
section
gave you the
101.
wrong number.
February is Black History Month. Are you interested
I
in
apologize
reading more
for that.
books by African American authors? Please stop by the media center.
I
in
really do
February.
apologize
Check
for
out
that.
our display of great
We have a
books and
proportional,
lists by
y'all
Black
should have
authors.
caught me for that. So we have a
That's all
proportional
the
side, which is
answers
9 and
that we have
15.
today.
Okay, I wrote 12.
I need the following students to the
I'm so
main
sorry.
office. Emily Atencio, Kinsley Floyd, Will Moore, Kaylee Streitzel, Timothy
Yes,
Sanders,
Kim.
Shemaya Flagler, Luigi Oliverio, Gavin Bowles. Please come to the main office at this time.
3.3. Awesome. Does that make sense to
Also,
y'all?
sixth grade math tutoring will not start until 3:30 in Ms. Dover's room.
Oh,
If
okay,
you
that
have
makes
sixth
sense.
grade math tutoring, please
So-
report to Ms. Dover's room at 3:30.
We're gonna give out y'all's tests. Okay, whoever